Hi everyone, good evening. So today we are going to review this 14 kilowatt grid connected solar PV system. So this is nothing but the output generated from this grid connected inverter, and this is nothing but grid connected inverter, where generally we call it as a grid tied inverter. And coming to the plant, so here you are going to have approximately two strings. Okay, so you have the upper set is nothing but 14 panels, and next these are the remaining 14 panels. Okay, so you have two sets of 14 and one more set is also 14. Okay, so here 14 solar panels are connected in series connection, which will act as an this will act as an string 1 and this will act as an string 2. So if you see this panel specification, so you can see the panel specification here. So the rating of this solar panel is 535 watt. I mean each panel will like an 535, and this is 535. So I can say that when you connect two panels, which is equal to 1 kilowatt. Okay, so operating voltage, I mean we have multiple parameters. Open circuit voltage is 49 volts and short circuit current is 13 amperes, and the maximum voltage actually what we require for the connections is 41 volts, and current is 12.85 amperes. Okay, so overall this is nothing but from the manufacturer Renew System India Private Limited from Maharashtra. So this each panel will act like an 535 watts. Generally we will consider it as a 500 watt panel. So each two solar panel. So this is solar panel 1 and this is solar panel 2 will constitute around approximately 14. So if you count completely, you have 28 solar panel. So this is an 14 kilowatt solar, I mean grid connected solar PV system. So here, so you can see here all the connections. Coming to the connections, here you can see here all the solar panels are connected in series connection. So the negative is connected to positive, and this negative is connected to positive, and this negative is connected to positive. So like this you can see here, this is completely one string. So this is a string 1 which is directly connected to the grid connected inverter. You can see the connection. So output of this, I mean negative is connected to positive, and this negative is connected to the positive, and this negative is connected to the positive. Like this you have 14 solar panels which are connected in series connection, and ultimately we can have here, so you can see ultimately how many wires are there. So here you are having only two sets, which is nothing but so one positive one negative is one set, next one positive one negative is another set. Resultantly you can see here, so here we are going to have two sets of solar panel. So this is set 1, set 2, and this is one set. So ultimately we have been fragmented and directly it is connected to the solar DC distribution line. Okay, so ultimately two strings are available. All those two strings are now you can see here. So resultantly the safety is enabled inside. So in order to have the required protection, and resultantly you have approximately this is string 1, this is string 2 is directly connected to our. So here the type of inverter used is a Growatt solar grid connected inverter, and you can have this. This is nothing but we have a GC, I mean SIM inside this, and we can see how many number of units has been generated. Today you can see here the total power. So this is 1.4 kilowatt, which is 14 kilowatt, the total power rated, and today it has been generated 54 units. Okay, so it has been generated 54 units. Okay, so today from morning onwards it has been generated 54 units, and next one today it has been generated, I mean total energy generated till date is 18.4 megawatt. Okay, I mean mega units, and now the solar giving an voltage of 479 volts, and PV1 is nothing but string 1, PV2 is another string which is giving 540 volts, and you can see here. So the AC supply you are having first phase, I mean line voltage is 436, next line voltage is 430 and next line voltage is 430, and you can see here. So individual currents are the phase, I mean line 1 is consuming 1.9 amperes, line 2 is consuming 2 amperes, line 3 is consuming 1.9 amperes, and so this is about the frequency of operation is 50 Hz with it's exactly it is maintaining. So this is how to set the parameters, and this is more information. This is all about this grow volt grid connected solar PV inverter. So you can see here all these are the Chinese brand, where we have all the top manufacturers who manufacture this solar plants is from grow watt. Okay, so here coming to this grow watt, so already we have been discussed. So the when you connect this solar string, so we are having each solar panel is of 14 volts, and we have been connected 14 volts into 14 number will constitute 580 volts. So each string, this string is carrying a voltage of 580 volts DC, and this is a second string which carries 580 volts DC. So both are connected to this grid connected inverter. Okay, so and when you come to this multiplication, so voltage is 580 volts, and current of each solar panel, already we have been shown you the current rating. So each panel is generating a current of 12.65. So when they are, I mean each string will generate a current of 12.85 amperes. So 12.85 in one string and 12.85 in another string, both are connected in series. Therefore, the resultant you are going to have the voltage of 580 volts into each string is carrying a current of 12.65 into 2 number. So when you multiply all these things, this is nothing but a 14 kilowatt grid connected inverter, and these are the specifications of this grid connected inverter. And you can see here, so here you have the specifications. So here the rating of this output, maximum output is 12 kilowatt. This is 12 kilowatt, and this operating with power factor of 0.9. Okay, so this resultantly this is nothing but 13 kilowatts, and the solar PV voltage, so maximum input voltage you can apply up to 1100 volts, and we are applying as from the series connection 580 volts DC, and nominal input voltage is 580 volts DC. So we are also applying directly 580 volts DC, and coming to the current, so PV ISC, PV ISC. So the PV short circuit current is 16 amperes. So maximum output current it can deliver is 12 kilowatt or 13.2 VA. So nominal output voltage, this is an 3 wire. So you can see here, this is directly connected to the grid. So this is nothing but 3 wire with 3 wire with neutral, and operating with an frequency of 50 to 60 Hz, and this comes with ingress protection of IP66. IP66 means IP is called ingress protection, and 6 it is dust proof, as well as it protects from the water jet. So if you sprinkle the water also, nothing will happen. Why? Because this will be kept in open atmosphere. So this is the incoming line, and from the outcome, we have an internally we have an circuit breaker, as well as you have an HRC fuse, which is nothing but, these are nothing but HRC fuse, high rupture capacity fuses present here. These are the two HRC fuses, and output of this is connected to this input as string inverter, and you have the output. So from this output it is connected to here, and you can see here now it is generating 3-phase supply R, Y, B, and the system is in which condition? On condition, since you have the required amount of illumination, and here you can see how much voltage they are generating individually. Okay, so since it is having more light, you are unable to observe it. So here you can have the complete parameters, kilowatts and kVA, and the frequency of operation. So this is how this 14 kilowatt solar PV system is constructed in each individual module, and this is well maintained neatly. So that's why the system is operating very happily and successfully. So this is how we have an overall view. So we have approximately each panel is of 530 watts, and so we have approximately, if you count, you have 28 panel, so each is of 500, so each 2 panels will constitute 1 kilowatt, so approximately the total system is 15 kilowatt. So this complete string, okay, so this is complete string, you can see from the starting. So this is string 1, okay, so this is completely a string 1, okay, so this is completely string 2, both are having a one positive terminal and negative terminal, and all those are connected to this solar DC distribution system with the help of an high rupture capacity fuses, and output of this you can see here. So you have only 2 pairs, okay, one pair is string 1 and next one is pair 2, and all these are given to the safety, and output of this safety is bought here and it is given to this so solar inverter, and output of this is connected to the AC, and output is directly, this output is directly fed to the grid. So this is nothing but what have been fed to the grid. So on our average, if you calculate this 14 kilowatt, 1 kilowatt will generate 5 units per day. So this will generate 5 units per day. So approximately 14 into 5, okay. So 14 into 5 per day it generates 70 units. So today you can see here, so what in the statistics it is showing as actually it has to generate 70 units, it already generated 54 units. So now it is operating well, so it has to generate actually 70 units. Today we have little bit less heat, so that is why it is generated only 54 units, and completely 70 into 30 days on our average, this unit will generate 2100 units per month. So these people use it to get so minimum 2000 unit monthly. So this 2000 rupees already they are generating automatically, they use it to get very less amount of zero electricity bill on our average. So this is like a big function hall. So this LKR functional hall, the location is at Pangirigiri. So if anyone want this kind of installation, you can contact us, we will help you in installation and how to install this grid connected solar PV system. Hope the video is useful to you. If you feel the video is useful, please like, share and subscribe, and please try to promote this sort of channel which are useful to the society as well as for the students. Thank you for watching.